So hello everyone, let's look into the another circuit. Now this task requires us to make something like the Night Rider mode. We have done it earlier, but the something that new was introduced in this was external interrupt using the push button. So let's look into that how to do it. First, let's look into the header file. In this task, we are required to use 6 LEDs, one push button, and resistors for the LEDs. So firstly, we have to give the names to the customized library that we would be using, the header files, then the library for basic configurations, and most importantly for the CMSIS, the SAM.h library, and then created an enum which they has like enum is for making it much more simpler to understand for us humans. So input suggesting it to be 0 and output mode is number 1. And then we have another enum for high state and low state, and another for system is running and the system is stop. So stop means 0 and a system is running means 1. The other thing that the push button does is we have a start button, we have a stop and a reset. So if you press it for one time, it starts. Then we have reset. If we press it again, reset, and then if we press it third time. So that's what happens. So we are using the 6 LEDs and given it a proper night rider time period to be 1000, and then the debounce delay because sometimes the system doesn't actually acknowledge these changes or sometimes gives the false value. So for that there is a debounce delay. And the port which we would be using is A. We could use either B or A, it's up to you. Both ports have 32 pins. It depends on what kind of board you are using. So Arduino Nano IoT 33, even though it says like SMD21 has 32 ports for a particular port, but when you look into the configuration of it, it basically depends on different types of models that we are using and whether they are actually the MCU is mapped to the actual peripheral pins or not. Then we have the class, which basically defines the value for TCC instance, TCC number, IRQ number, period in milliseconds, and is it actually running. So all those have their own type of data value, which could be seen here. And then what kind of function we are configuring our GPIO pin, general purpose pin, and then writing onto it. Then different types of states, whether they are on or off, and depending on what pins that we have selected. Timers, timers need to stop, start, and what period that they are actually dealing with. And then the global interrupt, external interrupt setup, initiating the LEDs, clearing all the LEDs, night rider setup, handle push button, run task all these functions, then the external interrupt handler for that, timer interrupt handler, and other global variables. Right, let's move on to the .cpp file. Now the particular port pins are defined 10, 11, 18, 20, 21, 16. Again, the global variable system stopped. At the very beginning, we want the system to be at rest state. And then starting at the last button count, let's initiating the last button count to be 0. And as we press the button, the state changes. Same, the last button time would be 0 at the very beginning when we start with it, and a timer control counter would at the very beginning would be ticking, and the index and direction, whether we are moving from left to right or right to left, it depends on that. And the button count, whether it was first time press, second time press, or third time, depending on that. Then the port number, which would be to be by default would be returning 0 because we are selecting the port A. Then again, I told you like pins are 32, but starting from 0, it gives you 31. And then configuring all those pin, writing onto all those pin and selecting a particular pin and then turning it on only that particular pin that we have selected, then the state. Again, the same thing. Then the timer, so in this case, the timer counter 0 was selected because we would be dealing, you could either select other if you wanted to, just to make it much more easier, and we are dealing with the clock cycle 48. So this is a circuit, 6 LEDs right here, one push button to press it, and let's run the code. So it just tested all the LEDs. If you wanted to see, let me just press it again. So it tested every LED like it's properly connected, and let's play around with it. So first push button, so pressing it once, starting it, and it reverses it. Pressing it again would stop it. Right there, it stopped whatever was clear. Then again it would reset it, and again starting it, Okay, just a second. Maybe something got loosed. Okay, we are currently at reset. Let's just press it once again. Okay, it started it again. And it will move back. Again, if I stop it, it stops at the particular LED that it was at, and then reset it. So that's how we do it. Thanks for watching the video.